Someone one time said I should talk about electromagnetic induction. Electromagnetic induction. And this is basically a concept which most of us use. We have seen it, but we don't know. It is in vehicles, in alternators, it is in electric belts, it is in so many other areas where we have magnetism and we can induce electricity as a result of a changing magnetic field. So in this area, you find that people experience, or items experience, a PD or an EMF being induced as a result of current coming in as a result of the changing magnetic flux in a coil. And it is basically on two definitions. These definitions are what we call laws. Laws of electromagnetic induction. And there are two laws. Most of you who have been to school in O level, you've heard of what we call the Lenz's law. You've also heard of what we call the Faraday's law. Those are the two basic laws we talk about that bring about electromagnetic induction. And in the meantime, as we wait for more guys to join so that I can answer people's questions, I can be talking about them in the meantime. So in this case, we have two laws. The first one is Faraday or Lenz, and then I can begin with Andy. Let me start with Faraday. Faraday's law states that the magnitude of the induced EMF is directly proportional to the rate of change of the flux linkage. So this says that the magnitude of induced EMF is directly proportional to the rate of change of flux linkage. That's how it can be stated in English, but we can have a version which is mathematical. The mathematical version is in a sense that if I talk about this in a mathematical form, then it says EMF induced capital E is directly proportional to the rate of change of the flux. The flux changes with the rate of dt, dn phi dt. And if you remove the proportionality sign, then it accounts for Lenz's law. So that is Faraday's law. When you come to Lenz's law, what does it state? So Lenz's law states that the EMF induced acts in such a way that it opposes the change that causes it. The EMF induced acts in such a way that it opposes the change causing it. Or sometimes you say the direction of the induced EMF is in such a way that it opposes, or it tends to oppose the direction or the change that is producing it. And in this case, if you look at, for example, a magnet, if you bring a magnet whose polarity is defined, maybe north pole is this side, and you bring this magnet very close to a coil, then this coil is going to induce an EMF as if it is going to put here a north pole when the magnet is being thrust this side towards the coil. Then this side it will induce a south what? South pole. Whereas if you reverse and now try to take away the magnet, the EMF that is going to be induced in the coil is going to be in such a way that it will induce here a south pole, here it will induce a north pole. So it will induce a south as if it's trying to attract it back, yet the magnet now is going away. So it is acting in the opposite sense. Instead of supporting the magnet to go, it is trying to pull it back. So it is acting in the opposite sense. It is trying to oppose the change causing it. So even the first coil, if the EMF was being induced in a sense that as the magnet was being thrust towards the coil, it was inducing a north pole. The north pole was trying to oppose the incoming polarity. So here, there it is trying to oppose the change that is doing what? Causing it.